Every 7 seconds, a worker is injured on the job in the United States. Most of these injuries were 100% preventable if the right control had been in place. There's a proven system that eliminates guesswork and stops injuries before they happen. It's called the hierarchy of controls, and by the end of this training, you'll know exactly how to apply it. This isn't just theory, this is exactly what OSHA and NIOSH require for compliance in manufacturing. Most people think PPE, gloves, goggles, is the main way to stay safe. But PPE is actually the weakest link, because it only works if every person uses it correctly, every time. That's why NIOSH created the hierarchy of controls, starting with the most reliable, human error-proof solutions, only falling back to PPE when nothing else works. This is a legal expectation. Under OSHA's General Duty Clause, employers must control recognized hazards, and inspectors check whether higher-level controls were considered before PPE. Quick knowledge check. If a machine has an exposed blade that could cut a worker's hand, what's the first thing you should try? Pause here and think it through. Eliminate the hazard, guard the blade, or hand out cut-resistant gloves. Level 1. Elimination. This means physically removing the hazard entirely. No hazard, no risk, period. Example 1. Instead of using a toxic solvent to clean parts, a manufacturer switches to an automated ultrasonic cleaning system with water-based solution. The hazardous chemical is gone completely. Example 2. A plant redesigns its process so parts move directly from molding to packaging on one continuous automated line, removing the manual transfer step entirely. Example 3. Instead of storing unused hazardous chemicals in the plant indefinitely, facilities properly dispose of them right away, eliminating the ongoing storage hazard rather than managing it. Example 4. Instead of requiring workers to climb a ladder to reach an elevated task, the process is redesigned so the task is performed at ground level entirely, removing the fall hazard altogether. Elimination is the gold standard because it requires zero ongoing effort. But realistically, it's not always possible. Sometimes the hazardous process is essential to the job. Take a moment now to think of one hazard at your own workstation that could actually be eliminated, not controlled, not reduced, completely eliminated. Note it down for your own reference. Level 2. Substitution. When you can't eliminate the hazard, replace it with something less dangerous. Example 1. Swapping a solvent-based paint for a water-based low-VOC alternative. Similar finish quality, dramatically lower health risk. Example 2. Replacing a high-vibration hand tool with a low-vibration model to prevent long-term nerve damage. Example 3. Using a lower concentration chemical solution wherever the process allows, for instance, a diluted cleaning solution instead of full strength, reduces the severity of exposure without changing the task. Example 4. Switching from a powdered form of a chemical to a pellet or liquid form reduces how easily it becomes airborne, lowering inhalation risk significantly. The key regulatory point. OSHA's Hazard Communication Standard requires you to evaluate every substitute carefully. A safer chemical still needs a safety data sheet review first. Never substitute one hazard for another you haven't fully evaluated. That's a common compliance failure inspectors look for. Level 3. Engineering controls. This is where most manufacturing safety investment happens, physically isolating people from hazards using design and technology. Example 1. Machine guards over rotating blades and light curtains that stop a press the instant a hand crosses the sensor. Example 2. Working inside a fume hood or enclosure to keep airborne hazards contained and away from the worker's breathing zone entirely. Engineering controls are highly effective because the safety happens automatically, built into the environment itself, not dependent on memory. Local exhaust ventilation is critical for compliance. OSHA's air contaminant standards require airborne hazards like welding fumes to be captured at the source. Interlocked guards prevent equipment from starting unless the guard is properly closed and locked in place. Example 5. Installing physical guarding around pinch points on conveyors and rollers so hands can never physically reach the hazard zone. Scenario: a worker disables a machine guard because it's slowing down production. What's wrong with this, and what should happen next? Pause and think it through. Correct answer: bypassing a machine guard is consistently one of OSHA's top 10 most cited violations in general industry and should trigger an immediate stop work order. Level 4. Administrative controls. These change how and when work is done through training, procedures, signage, and scheduling. Example 1. Job rotation. Moving workers between high-repetition tasks and lower-strain tasks throughout the shift. Lockout-tagout is a hybrid control. The physical lock is engineering, while the written procedure and training are administrative. It's consistently among OSHA's top 5 most cited standards. Example 3. Adjusting work schedules and shift lengths to avoid fatigue-related errors, especially on tasks requiring sustained attention. Example 4. Posting clear warning signs at hazardous zones, like laser operation areas or high-voltage panels, so workers know to take precautions before entering. Training itself is an administrative control. Workers must be retrained whenever a process, tool, or hazard changes. Clear floor markings for pedestrian walkways and forklift lanes reduce accidents just by guiding behavior visually. Think of one administrative control at your facility that only works because everyone follows it perfectly. Consider what happens if just one person skips it. Level 5. Personal protective equipment. This is your last line of defense, not your first. This includes hard hats, safety glasses, hearing protection, gloves, respirators, and steel-toe boots. OSHA's PPE standard requires employers to assess hazards first, then select PPE that matches the risk. Example 1. Choosing gloves that are chemically compatible with the specific substance being handled. A general-purpose glove offers almost no protection against certain solvents. Example 2. Hearing protection rated for the specific decibel level of the equipment. Standard earplugs may not be sufficient near high-decibel stamping presses. The biggest compliance mistake isn't forgetting PPE, it's using the wrong PPE for the hazard or relying on PPE alone instead of the controls above it. Proper fit matters too. A respirator that doesn't seal correctly or gloves that are the wrong size offer almost no real protection. Final challenge before we recap. If PPE is the weakest control, why do so many companies rely on it as their main safety strategy? Pause and really think about that one. Let's put it all together. A stamping press operation has a history of hand injuries. Here's how a plant applies the full hierarchy, step by step. First, can we eliminate manual part loading entirely? Yes, an automated feeder removes hands from the danger zone completely. For presses where full automation isn't possible, they add light curtains and two-hand controls, plus lockout-tagout for all maintenance. Finally, cut-resistant gloves are still issued as PPE, an added layer, not the main fix. Result: injury rates drop sharply because every level of the hierarchy worked together. Let's lock this in. From most effective to least: elimination, substitution, engineering controls, administrative controls, and PPE. Always start at the top of this list and only move down when the level above genuinely isn't feasible, not because it's easier or cheaper. Before you finish, take a moment to consider which level of the hierarchy your own work area struggles with the most: engineering controls, administrative discipline, or PPE compliance. Keep that in mind as you return to your station. This concludes your hierarchy of controls training. Complete your knowledge check, and remember, a hazard understood is a hazard controlled.